Hello everyone, welcome back to my additional mathematics channel. For today's video teaching lesson, I will focus on differentiation in kinematics of linear motion, relationship between the displacement function, velocity function, and acceleration function. So in differentiation for a function y equal to fx, we have the dy dx, right? The dy dx means the rate of change of y with respect to x. This concept can be used for the movement of a particle along a straight line. For instance, displacement as of a moving particle is a function of time t, which is s equal to ft. So its derivative ds dt is a rate of change of s with respect to t. ds dt is actually velocity function of particle at time t. So we say v is actually a function in terms of the t. So v is ds dt. So the relationship between the displacement function s equal to ft, velocity function v equal to gt, and acceleration function a equal to ht can be simplified as follows. It means that if you are given displacement, you can differentiate to get velocity. Okay, so velocity is ds dt. And if you are given velocity, you can differentiate velocity with respect to time to get acceleration. So acceleration is dv dt. Alright, or you can differentiate directly from the displacement to get the acceleration, but you need to find 2 times of the differentiation, which is d2x dt squared, or we call a second derivative. Alright, so let's have a look at the example number 6. Today we will discuss the example 6, and also we will discuss self-practice exercise 8.3. Alright, so I will try to explain to you in detail about the example 6. Then after that, I will try to guide you how to solve the exercise. Self-practice self-exercise 8.3 is in your textbook page 261. So we are going to go through all the questions one by one so that you can understand the concept of differentiation in kinematics of linear motion. So guys, before we start the class, you must understand s is displacement of a particle. So if you differentiate ds dt, you get velocity of particle. If you differentiate the velocity with respect to time, you will get acceleration of a particle. If we integrate the acceleration, then we will get velocity. Same thing if we integrate the velocity, we get displacement. So we are going to do reverse way using integration. Now let's have a look at example 6. Now let's discuss example 6. A particle moves along a straight line. At time t seconds after it starts moving, its displacement s is given 3 plus 2t minus t squared, where t is the time in seconds. Determine the velocity of the function and acceleration of the function of the particle. Okay, for this question, you are asking to find the velocity. So you have to do the SDT, right? 2 minus 2t. How you get 2 minus 2t? You differentiate the s. And if you want to get acceleration, you have to differentiate the velocity, which is -2. Now we have three graphs. One is the s, which is quadratic, s equal to 3 plus 2t minus t squared. And we also have the function, which is v, 2 minus 2t is a straight line. Okay, and then we have the acceleration, which is just a constant, a is -2. So we are going to draw sketch all this on the graph. So first of all, actually we can just find the intercept and x-intercept and y-intercept, but here we have s-intercept and t-intercept. So by looking at the displacement s equal to 3 plus 2t minus t squared, we are going to sketch the graph, which looks like an N-shaped graph, right? So basically we need to find the intercept. So when t is 0, the s is 3, and we also need to find the maximum point because this is an N shape. So the maximum point can be found easily. You have learned the s dt divided by x, right? ds dt equal to 0. So we will get the turning point. You can always use the differentiation to find the turning point. Alright, example like you use dy dx equal to 0, you can find the turning point. Here we will use ds dt equal to 0, and the turning point is happen as 2 minus 2t equal to 0, t equal to 1. Right, when t equal to 1, the s is 4, that is the maximum point. Then we will find the intercept. We let the s equal to 0 and we solve the intercept. So we will get t equal to -1 and 3, but obviously negative is not logic for the time. So we will just reject the negative part of the time. So we plug in the x-intercept or the t-intercept, and the maximum point we can actually sketch an N shape for the displacement with respect to time. And for acceleration, we'll get a straight line, which is horizontal line, because it's not depends on the time. So acceleration is uniform, a equal to -2. So it's just a horizontal line, as I show in green color line. So a is -2. Okay, now I'm going to sketch the displacement graph, and also I'm going to sketch the graph for the velocity, which is actually a straight line, right? Okay, so for displacement is a quadratic, is an N shape with the intercept at the s is 3 and 0, 3 at the t. So that is actually the function for the displacement. It's an N shape with a maximum point 1, 4, with the intercept at 3, 3, 0 and 0, 0 and 0, 3. And then for the function of the velocity, we can actually draw a straight line, but the subject, the vertical axis will be v, and the horizontal axis will be t, and the gradient is -2. It shows that the line is going down, right? The gradient is negative, so we will find the best 2 points is either we let the t0 we get s2, and then we let the v0 we get t1. So we can draw a straight line for velocity by finding 2 points. The best point is actually use a x and y intercept, but here we use a t and s, okay, intercept. So let's draw the straight line for the velocity function, and for the acceleration we will get a horizontal line, right? Okay, so that is actually how we sketch the function. The domain is given from 0 to 3. So actually we have to follow the domain given. Alright, so the graph For the displacement, we can label as s equal to 3 plus 2t minus t squared. And for the velocity, we can use v equal to 2 minus 2t. And for the acceleration, it's just a equal to negative 2. Meaning that we draw all the three graphs. Okay, we sketch all the three graphs on the same axis because the instructions say we need to sketch, right? Okay, now let's proceed to example 6. For B, on the same diagram, sketch a graph of function s. We have sketched it. And then for the V, for the time from 0 to 3, and explain the motion of the particle from point O for the interval. Okay, so we need to explain for the motion. Okay, so we have to study how the particle move. That's so-called motion. So we will use the line number to explain. So at the time t0, the particle is actually displaced to 3 meter, right? So it starts at the 3 meter from the fixed point, and then after that, when t equal to 1 second, the particle will actually move to another place, which is 4 meter to the right. Just now it started at the 3 meter to the right of the fixed point. Now it will move, okay, to the 4 meter from the fixed point after 1 second. And the acceleration is negative 2 and velocity is 2 meter per second at the starting point when time is 0. That's how we explain, okay, from beginning when t is 0. Okay, when t equal to 1, we will find the speed, the velocity of the particle. It looks like it is at the t-axis. That means the velocity is actually at that point, the velocity is 0, right? Okay, so at t equal to 1, the velocity is 0, right? So that's how we explain. So when we explain the motion, means we want to know the speed and the acceleration of the particle, and the acceleration remain unchanged with the time, still negative 2, right? Okay, so let's proceed to the next point, which is when the time is equivalent to 3 seconds, what will happen to the particle? So we need to study the point. Okay, when the time is 3 seconds, we need to find out the displacement for the particle. So it seems like the displacement is actually 0, right? So it go back to the fixed point, and then its acceleration still remain negative 2, and the speed is actually if you substitute, you will get 2 minus 2 times 3, which is 2 minus 6, which is negative 4. So we are having a negative 4 meter per second. It shows that it is moving to the left when the v is less than 0. Okay, that is how you explain the motion of the particle, by finding the acceleration, finding the displacement, and finding the velocity of the particle. Alright, then if possible, we will actually try to label and write down the acceleration, the time, and also the displacement for the particle for every moment. We call it instantaneous. Okay, so after we have labeled everything, we can draw actually number line to show how the particle move. So from the graph and the number line, we can show that the particle actually move in such a way. Okay, it is found that the displacement of the particle at the t equal to 0, we can write in a sentence. Okay, the displacement at the t equal to 0 is actually the distance from the fixed point is how many meter when t0? Of course, you read the graph, it should be 3 meter, right, from the fixed point. So that is how we label. When t is 0, we will label 3 meter from the fixed point O. That is the starting point for the particle before it starts to move. Alright, so when t0, the particle is actually at the fixed point O 3 meter to the right of the fixed point, and then it starts with the initial velocity 2. We need to write in a complete sentence. The initial velocity is 2 meters per second, meaning that when the time is 0, the particle is actually having the speed 2 meters per second, and it is actually having the acceleration -2. It means the speed is decreasing because the A is actually -2 meters per second. So you can see that the speed is decreasing, right? So we have to explain in detail for every moment for the movement of the particle, so that we can actually describe how the particle move. So when t equal to 1, just now we have actually focused on the starting point. Then when t equal to 1, the particle changes the direction. Right? Changes the direction is very important keywords. At the turning point, okay, the particle changes its direction. It happens when time is 1. At that time, the particle's displacement from the fixed point O is maximum. It's the furthest from the fixed point. So we call it as maximum displacement, right? The maximum displacement is always happen when the particle change the direction. So the maximum displacement is actually 4 meter, right? Okay, so we have described the displacement, which is so-called maximum displacement, and then the acceleration at that moment when the time equal to 1 is actually still the same. The acceleration is actually not depends on the time, but the velocity, it was 0 meter per second, because the particle stopped, isn't it? You can see the purple line is cutting the t-axis, meaning that at time equal to 1, the velocity is 0, and then the acceleration is remain as -2. The acceleration is still -2 meter per second. All right, so we need to be very careful when we describe the movement of the particle at instantaneous point. Okay, now we want to describe the movement of the particle when the time is 3 seconds. What happened when the time is equal to 3 seconds? The particle reaches the original fixed point O, right? Because its displacement is 0. So at the time t second, the particle reach the fixed point O, where its displacement is 0, right? So we can see that at the t equal to 3, the displacement is 0 meter, and hence we can actually find out the velocity of the particle. The velocity is seems like -4 meter per second, it shows that the particle is actually moving to the left, right? It changed the direction, and when v is less than 0, it means the particle is heading to the left, and its acceleration is still remain unchanged, which is -2, right? So the acceleration is not affected by the time. It will actually uniform, which is -2 meter per second per second. Okay, so we have described the movement of the particle between 0 to 3. So if we want to find the total distance traveled by the particle from t equal to 0 until t equal to 3, so it's actually easier if we can use a number line, right, from 3, and then it will go to 4, which is travel 1 meter, and then when it go back to the fixed point, there's another same distance 1 meter, right, before it actually proceed to the displacement, which is actually stop at the point when t equal to 3. The displacement is actually 0, which is a fixed point. So we need to plus with another 3. So the total distance is 1 plus 1 plus 3, which is 5 meters. Alright? So we need to be very careful when we count the total distance by using the number line. For the next exercise, exercise 8.3, number 1, determine the velocity function in terms of the t for a particle that moves along a line in each of the following using differentiation. So let's differentiate the s with respect to time. Before that, we need to expand. So v is the s dt, so we just differentiate, we get 4 minus 8t plus 3t squared. So that is actually velocity, which is ds dt. For b, it's very simple. We differentiate, we get 16 minus 2t. And then for the c, we just differentiate. ds dt is actually 6t squared minus 8t plus 2. Right? It's very simple. So let's proceed to the next one. For the d, we just expand first. We expand carefully. We have s equal to 9t cubed plus 64 plus t5. So ds dt will be 27 t squared plus 24 t cubed plus 5t4. This is the velocity. For the e, also the same. We will just expand. So after expand, velocity is ds dt, which is actually 6t squared minus 18t minus 5. Alright, so this is how we get velocity from the displacement. For the f, also the same. We will do ds dt, so it's 3 times 1/3 t squared minus 6t plus 5. Acceleration. For the acceleration, we need to differentiate the displacement, and then we have to differentiate the velocity. So let's start with the s. For s, displacement, we have 1/3 t cubed minus 1/2 t squared plus 4t. Firstly, we do ds dt to get the velocity. And then from the velocity, we will do another time of differentiation, which is dv dt. So we will get 2t minus 1, which is the acceleration. So meaning that we need to do 2 times of differentiation from the displacement to get the acceleration. So for b, we have dv dt, which is actually 6t minus 10. After we differentiate the s to get the v, we differentiate the v to get the a, which is acceleration. Okay, the c also the same. We do ds dt, so it's velocity 8 minus 6t squared, and from the dv dt we get -12t, which is the acceleration. Alright, so let's proceed to the next question for the D, E, F. So for D, we will dv dt directly because we are given the V. So we will get 2 times by minus 3t, and then we have to differentiate in the bracket -3. This is a chain rule, so we have to simplify to the simplest form. Now how about for E? Also the same, we will do dv dt, so we get 2 times 3, which is 6t power 1, and this one minus t -1, it will be negative times with -1 t minus 2, so we will get plus 1 over t squared. Okay, be careful. F, we will actually do again 3 times 6 will be 18t squared, and 4 minus 4t -2, so we will get actually become plus 8 over t cubed. So be careful again because the power is negative. So normally we need to convert -4 over t squared as -4t -2 before we differentiate. Alright, so be careful when the power is negative. So we will proceed to the next question, which is question number 3. A particle moves along a straight line and passes through a fixed point O. Its displacement as meter is given by s equal to 8 plus 2t minus t squared, where t is the time in second after it starts moving. Determine the expression for the velocity function v and acceleration function of the particle in terms of t. So in this case, we have to do ds dt to get the velocity, which is 2 minus 2t, and we have to differentiate the velocity to get the acceleration, which is -2. Alright, so we are going to sketch the graphs of displacement, velocity and acceleration function of the particle for the time from 0 to 4, and then we have to interpret the graphs. This is very challenging. So first of all, we will let x equal to 0. The s is the displacement, and we will solve the time, which is actually factorized. The time is 4. The time which is -2 we'll ignore, and with the time which is equal to 4, we will substitute into the velocity. When the time is 4 seconds, what is the velocity for the particle? So it's actually substitute into 2 minus 2t, so we'll get the answer, which is 2 minus 2 times 4, which is -6. Alright, so that means the velocity of the particle is -6 when the time is 4 seconds. So we can write as 4 -6. Alright, so actually we will let the ds dt equal to 0, and then we find out that t is equal to 1. When the velocity is 0, the time is 1. Alright, so when time is 1, we have to find the displacement. We get 9, and then when time is 0, the displacement is 8, the velocity is 2, and the acceleration is -2. So we'll substitute all the time into the displacement, into velocity, and into acceleration, and then only we can sketch the graph. Right? So we are going to sketch the graph based on the information s equal to 0, t equal to 4, and then t equal to -2. The negative part of the time we won't sketch any line. So we will label all the important points, especially when t equal to 4, the velocity is -6, we have 1 point. And then when the t equal to 1, the displacement is actually 9. So we have 1, 9, right? So we can sketch the maximum point. okay, of the n shape. Okay, we can also find the intercept when t0, displacement is 8, right? We can label 8 there. Okay, after we label the 8, then only we can sketch the graph, right? So we are going to plot all the important points first. Example, we need the 0, 8, we need the 1, 9 for the maximum point. And also we need the 4, 0 is actually when the displacement is 0, we have time which is 4, right? So based on all the information, we will actually plot the n shape. So for you to plot the n shape, you need to find the turning point which happen at t equal to 1 and the s is 9. So from there we can sketch a smooth n shape for the displacement function s equal to 8 plus 2t minus t squared, right? And we can also sketch the a, which is negative 2, is a horizontal green line, and the purple line is the function of velocity 2 minus 2t. So I'm going to describe the movement of the particle using the keywords. The particle start to move on the displacement of 8 meter from the fixed point O with the initial velocity of 2 meter per second and acceleration of negative 2 meter per second At the time t equal to 1, the particle is actually rest with the velocity 0 meter per second and start to change the direction to the left with its maximum displacement is 9 meter and acceleration of negative 2 meter per second Alright, at the time equal to 4 seconds, the particle actually reaches at the fixed point O with a velocity of negative 6 meter per second and its acceleration still remain with negative 2 meter per second throughout the time of 0 to 4. The acceleration of the movement of the particle is remain unchanged. The total distance that passes through by the particle in that duration of time is actually 9 minus 8, and then we have to plus with the 9, so it's actually 10 meter. Right? That is the total distance traveled by the particle. So in order to find the total distance traveled by the particle, we need to study the movement of the particle so that we are aware when it changes direction. Alright? So that's all about solving problem involving kinematic of linear motion for self-practice 8.3. I really hope that my sharing do help you to have a better understanding of this topic. Okay then, bye bye and have a nice day.